Find all the real zeros of the polynomial. Use the quadratic formula if necessary. We will begin by finding all of the factors of the constant term minus 7. Those factors would be plus or minus 1 and plus or minus 7. Then we will find all of the possible factors of the leading coefficient 3. Those possible factors would be plus or minus 1 and plus or minus 3. Then we find all of the ratios p over q, which would represent all of the possible rational roots for the polynomial. So this would be plus or minus 1, plus or minus 1/3, plus or minus 7, or plus or minus 7/3. Then we'll choose one of these values and perform a synthetic division. So let's use minus 1. We begin by writing our guess for a root, minus 1, in a little half a box, and then write the coefficients of the polynomial out to the right of that. Then we leave a space and draw a line. We bring the 3, the leading coefficient, down below the line. Multiply negative 1 by 3 and write it below the next number. That's minus 3. Now we add the numbers in that column. The result is 2. Now we multiply minus 1 by 2 and write that in the next position on the second line. Now we add these together and we wind up with minus 7. Multiply again. Minus 1 times minus 7 is positive 7. And when we add, we get 0. This 0 at the end of this bottom row tells us that negative 1 is a root. It also tells us that x plus 1 is a factor of this polynomial. The other factor would be found in the coefficients on the bottom row. So the other factor would be 3x squared plus 2x minus 7. So we have begun to factor the polynomial p of x. Now we can use the quadratic formula to find the other two roots. So we'll set 3x squared plus 2x minus 7 equal to 0. A is 3, B is 2, and C is minus 7 when we think about this quadratic equation as ax squared plus bx plus c equals 0. Now we'll use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a to find the other roots. So substituting into the quadratic formula, we have minus 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 7, all divided by 2 times 3. Now we can combine under the radical. So we have 4. Now we have minus a negative, which is going to be plus. And when we multiply 4 by 3 by 7, we have 84 all over 6. So this gives us x equals minus 2 plus or minus the square root of 88 over 6. 88 has a perfect square as a factor, and that perfect square is 4. So we would write minus 2 plus or minus the square root of 4 times 22 over 6. And we would do this because the square root of 4 is 2. So we can now write x equals minus 2 plus or minus 2 times the square root of 22 over 6. Now we have to be careful when we reduce and simplify. We'll need to factor a 2 out of the top. So we'll have 2 times minus 1 plus or minus the square root of 22 over 6. Now we can cancel the 2 and the 6 will make a 3 in the bottom. So we will have x equal to minus 1 plus or minus the square root of 22 over 3. You might sometimes see this written with a 1/3 factored from the whole thing. So we would have 1/3 times minus 1 plus or minus the square root of 22. So we have these roots, 1/3 times minus 1 plus or minus the square root of 22, and we have our root minus 1, giving us a total of 3, which is what we should have when we have a third degree polynomial.